Let me answer this question paper that came in August 2025. First question says, which of the following instruments can be used to measure accurately the internal diameter of a bottle top? To do this, we require a vernier caliper. A micrometer screw gauge cannot be used because it is designed to measure small lengths. So, for such an instance, it can't work. A meter cannot be used because it is designed to measure lengths that are in form of a straight line like this, not in a case of a bottle top that has caved surfaces. So a meter cannot be used. Same applies to a measuring tape. The best answer here is a vernier caliper. Question 2 says, which of the following contains a vector and a scalar? In which row is the size of the vector equal to the size of the scalar? Right. The question has two parts. The first part will determine the vector and the scalar, and in the second part of answering the question, we also require to validate if the size of the scalar is equal to the size of the vector. Alright, let's start with option A. The vector is given as displacement of a car. Yes, displacement is a vector and speed is a scalar. However, the magnitude, or rather the size of displacement and speed, are not the same. Okay, so in this case, option A is wrong. And let's go to option B. The vector is given as velocity, and yes, velocity is a vector, and the scalar is given as distance. Right. However, the magnitude of velocity and distance is not the same, so this option is also incorrect. Option C says the vector is given as velocity and the scalar is given as the speed, which is definitely correct. And it is also correct that the magnitude of velocity and speed is the same. Alright, so option C is definitely correct. Alright, question 3. Two forces of 5 Newton and 7 Newton act at right angles to each other as shown. What is the direction and resultant of the force? Okay, whenever two forces act at right angles, the direction of the resultant force is at the center. It acts at the center like this, and we can calculate the size of the resultant force by basically using Pythagoras theorem. So the resultant force is this one here. Okay, so if we say R is equal to A squared plus B squared, right? Okay, my A, let's say, is 5, my B is 7 squared. Right, so we'll have 7. Doing your basic math here will give you here a value of 74, which is approximately equal to 8.6. So my resultant vector is 8.6. Okay, the direction we have said is in this way, so it can either be this or this, and the size of the resultant vector is 8.6, so option C. Question 4. The diagram shows a journey for a car along a straight road. How much distance was covered after the brakes were applied to the car? Okay, for a velocity time graph, the instance where the brakes are applied, it means that wait, where is this? It means that the car was decelerating. So when brakes are applied, it means that the car is decelerating. So in this case, the equation simply requires us to calculate the distance on the part where the car was decelerating. And it should be noted that for a velocity time graph, the distance can be calculated by simply calculating the area under the graph. Okay, so the area under the graph, right, and the shape we're given for this part here is a triangle. The area of a triangle is half pH. Okay, so I'll just have I have there 10 by 35 minus 25. Okay, right, so I'll have half there, 10 times 10, and a value of 50 meters, which is corresponding to option B. Question 5. A body starts from rest and attains a speed of 20 meters per second in 2 seconds. The acceleration produced was, alright, for this question, let us use the formula that says A is equal to V minus U over T. Alright, V is the final velocity, and from the question we are told it's 20. Alright, minus U. U is the initial velocity, and the question has emphasized to say the body starts from rest, meaning that U is 0 and the time we're given is 2. So the acceleration is 10 meters per second squared, which is option B. Question 6. A feather and a small metal ball bearing are released at the same time in a vacuum. Which of the following statements is correct about the motion of these bodies? Remember, uh, when we say a vacuum, it just means a space where air resistance is negligible, meaning that when we release two objects, they fall at the same acceleration of 10 meters per second squared because there is no air resistance acting. So in this case, when we release a feather and a small metal ball, they should fall at the same time. Okay, so this is corresponding to option B. Right. Question 7. A force acting on a body may cause the following changes except its right. For option A, a force can definitely cause an acceleration. Suppose I have a body like this. When I apply force, I can cause this body to move, and as a result, the body can attain acceleration. Therefore, a force can cause acceleration. So this can be the answer. A force can as well can as well have an impact on the length of a body. Suppose I have a spring like this. It's, let's say, 3 centimeter. When I add a force here, it can cause this spring to extend. So to extend, meaning that a force can have an impact on the length of a body. So this is not correct as well. The only thing that a force cannot have an impact over is the mass of a body. Okay, so here my best answer is option C. Alright, question 8 says a body of mass 4 kg start from rest and after 4 seconds it acquires a speed of 20 meters per second. What force caused the change in velocity? Alright, the question is simply requiring us to calculate the acceleration. Alright, in order to do this, let us use the formula that says alright, sorry that acceleration is equal to v minus u over t. Alright, so acceleration will be equal to the v, which is the final velocity I'm given, is 20, and my u, since the question says starts from rest, meaning u is 0 and the time is 4 seconds, so my acceleration should be 5 meters per second squared, which is option A. Okay, question 9. The diagram shows the extension produced when a load is hung on a spring that obeys Hooke's law. Alright, which of the following expressions is used to solve for the extension? Okay, An extension is just an increase in length from the original length. So in this case, if we had no force applied on this body, and after we applied a certain force, uh, the body extended, we can simply calculate the extension E as being equal to AO1 minus AO1. So that's the formula of calculating extension. Right, this is corresponding to option D. Question 10. The following diagram shows an arrangement used to find the mass of a meteor. What is the mass of the meteor? The mass of this ruler here acts at the center. So it acts as the geometrical center of